This is a short video for anyone who might have missed class and needs some help with some solving equations review. So the first thing we need to look at are when we see an expression like this, there are variable terms and there are constant terms. So a variable is a term with one of these letters, right? Usually an X, but it could be any letter. It's a symbol that stands for some unknown value or some value that's changing. Then we have the constant terms. Constant just means a number. We also have coefficients. Coefficients are the numbers attached to the variable. So when I see 7x, our variable is x, and the coefficient is 7, so that means 7 times x. We can simplify expressions by combining like terms. So what we mean by like terms is that variable terms are alike, right? X and 2x are the same. We could put those together. Constant terms are alike, but we can't combine x's and non-x's. So for this example here, if we wanted to combine these terms, we could take the constant terms and put those together. 3 plus 8 is 11, minus 1 is 10. 7x minus 5x is 2x, plus 4x is 6x. So we can simplify by putting the x's together and then putting the constants together. Like terms also have to have the same exponent. So if I had a x and an x squared, those are not like terms. So we can't put an x with an x squared. And that'll come up a lot later on in this course. Cool, so let's go ahead and jump into some example problems, but before that, you can see that if we had this big polynomial here, and we'll see equations like this later on this year, this x cubed is the only x cubed, so it can't be combined with anything. So you can see in our final simplified version, x cubed is by itself. These two x squareds, those are alike. We got 3x squared minus x squared, so 2x squared total. And then the negative 7 and the plus 2 together make negative 5. Notice that this is not 7 and 2, this is negative 7 and 2, so that minus is attributed to the term in front of it. Something we're going to look a lot at today is something called the distributive property. You saw this in algebra. When we have a value times a binomial or a bigger polynomial like this, so meaning multiple terms getting multiplied at once, we can take that value and distribute it through the parentheses. So in this example, I've got negative 4 times 2x minus 3. So those parentheses tell me I'm multiplying, and I want to multiply that negative 4 times both of the terms. So negative 4 times 2x is negative 8x. Negative 4 times negative 3 is plus 12. You can see how bad my handwriting was when I was using a mouse. All right, so I like to do a step-by-step approach. A lot of students like that. So a step-by-step for solving pretty much any multi-step equation. We want to do distribution first. So if we see these parentheses, we want to take care of that first to help simplify. Then we want to take each side, the left side of the equation and the right side of the equation. And by the left side and right side, I mean on either side of the equal sign. So we simplify the left and the right side by combining like terms. And then we're going to start moving all the variables to one side, so all the x's to one side, and then all the constants to the other side. And we're going to solve with inverse or opposite operations. So let's go ahead and take a look at a couple examples here. So I'm going to grab these. And these are going to be pretty similar to what you see on your assignment. All right, so we'll start off pretty simple. We've got n minus 4n equals 12. It doesn't matter if the variable is x or n or b or a kitty cat face. It doesn't matter. It's just a symbol to represent some value that's unknown or some value that's changing. All right, so there's nothing to distribute here. We don't have any parentheses, but we do see some like terms on the left-hand side. So n minus 4n's gives us negative 3n's. So I've got negative 3 times n is equal to 12, but I don't want negative 3. At the end of the day, I just want plain n by itself. So to get rid of the negative 3, since right now we're multiplying times negative 3, I want to do the opposite of that. So the opposite of multiplying is to divide. So I'm going to divide both sides by negative 3. Okay, and if I do that, negative 3 divided by itself just kind of goes away, right? That becomes 1. And then 12 divided by negative 3 is negative 4. If we multiply or divide and we have opposite signs, we get a negative answer. All right, let's take a look at number 2 here. So on the right hand, again, we have no parentheses, so no need to distribute, but I've got some like terms, the 3 and the negative 6 here. So I'm going to put those together. So 3 minus 6 is negative 3. All right, now I've got everything simplified on the left and the right, but I want to get this k by itself. Our goal is to figure out what is k, right? At the end of the day, we want k equals something. So to get the k alone, I need to get rid of what's happening to it. Right now, we're taking this unknown number and we're subtracting 3 from it. I don't want to do that. So let's do the opposite, which would be to add 3, the opposite of a minus 3. Whatever we do to the right-hand side has to always be done to the left-hand side. So we're allowed to make these changes as long as we keep things equal. All right, so I get k is equal to 0. Kind of a weird answer, but that's totally okay. Now keep in mind, as you're working through these problems, you can always check yourself. So if I get k is equal to 0 and I'm feeling unsure about that answer, I can go back and plug it into the beginning and see if that comes out right. 0 plus 3 is 3, minus 6 is negative 3. So that seems right. We can do the same thing over here. Negative 4 minus negative 16, so negative 4 plus 16 would give me 12. All right, let's take a look at number 3, which is a little more complicated. I'm going to erase this to get some room. So this time we have some parentheses, so we want to deal with those first. Remember, our step-by-step distribute is always the first thing we should do. So I'm going to take this 6, I'm going to multiply through the parentheses. So I get 6 times negative 8, negative 48, ends. 6 times negative 8, negative 48. On the other side, we're just going to leave it. It's already simplified. Okay, so we can't combine any like terms, right? We have a single n term, a single constant term on the left, same thing on the right. So what we need to do next is get all the variables, all the n's on one side, all the numbers on the other. So I'm going to add 48n to both sides. Now, it doesn't matter if I could have also added 8n to move everything to the right-hand side. It doesn't really matter. I just chose to do it this way because then I'll end up with a positive number over here, and I'd rather deal with that. All right, so negative 8 plus 48 is positive 40. All right, so I've got my n's over here. All the n's are on the left. I want to get all the constants away from it, right? Again, at the end of the day, we want n equals something. So right now, we're multiplying n by 40, we're adding 32. So to get rid of that plus 32, we can do the opposite, which would be to subtract 32. I'm going to run out of room here, but that's okay. All right, so I'm just going to jump down here. Let's just ignore this. All right, I got negative 48 minus 32. So it's going to be negative 50 plus 30 more, so negative 80. Just double check my math there. Yeah. All right, so 40 n's equal to negative 80. I don't want 40 n's. I want single n. Oh, there we go. I want a single n. So the opposite of multiplying by 40 would be to divide by 40. Again, we're always doing inverse or opposite operations to get rid of the extra nonsense. We just want the n by itself. All right, just want the variable by itself. So negative 80 divided by 40 is negative 2. Again, if you want to check your answer, you can always go back and plug negative 2 in to check. All right, let's do one more here. Since we scratched that out, let's go over here to number 6. All right, so lots of stuff going on in this one. We've got 2 sets of parentheses on both sides of the equation. So I want to deal with those first, and then we can simplify by combining like terms. Again, this step-by-step approach is always really helpful to know what to do first. All right, so let's distribute. All right, so the negative 5 is going to get multiplied by everything in the parentheses. Okay. Negative 2 times n, negative 2 times negative 3, negative times a negative comes out positive, right? Those same sign comes out positive. All right, on the right-hand side, we've got some like terms. 1 plus 6 is 7. All right, so again, we've got n's on both sides. We want to get all those put together. It doesn't matter which direction I go. Last time we moved everything to the left, so this time let's move it to the right. Again, it doesn't matter. Some people really prefer to have their variables all on the left-hand side, but it doesn't matter. As long as we're following through on our logic, we should get to the right answer. So we end up with this. Negative 35 is equal to 7 plus 3 times some number. We don't want 3 times a number plus 7. We just want the number. So let's get rid of that plus 7. The opposite of plus 7 is minus 7. Finally, I've got 3 times some number is equal to negative 42. So I don't want to do multiplying by 3, so I do the opposite there. Divide by 3, the inverse operation, to get rid of it. And I'm down to, what's that going to be, 14? Yeah, cool. All right, I hope this helped you get started with this first assignment, reviewing some of those basics you should have learned in Algebra 1-2. If you still need more help, remember that during flex time, I'm always available. I'll have your normal class meeting open if you want to drop in and check your answers. That I want your work to look like this. I want to see line by line, step by step algebra, where we keep things very organized. We have our equal sign kind of straight down the page, and I'm not the most organized person. You can see I'm a little bit messy, but even if you can do some of this stuff in your head, every time you skip a step, you really do risk making a mistake. And I see a lot of students who try to work quickly through things. They don't sort of go through this meticulous way of doing algebra. And it'll come back to bite you later when we get to more complicated problems. If you're used to doing this step-by-step process, right, following the logic of algebra to solve, I promise it will help you in the future. So try to follow my model and solve these problems pretty similar to the way I do it.